Hello friends, today we'll talk about caching. So caching is a process of copying data into the cache. Cache is basically a temporary storage primarily used to improve the performance of an application. So there are around four scenarios in which you can use caching. The first scenario is when you have raw data which will process it and show it on your application. So your application, every time when it needs to show the data, it has to process the data and show it on the UI. So in order to avoid computing data from raw data again and again on every request, what you can do is basically take the raw data, compute it one time, and save the computed data as processed data into the cache, so that now your application, instead of taking the raw data, process it and show it on the UI, it can directly take the processed data from the cache, and that's how it can save repeated computation every time. The second scenario is when you have data in your slow storage and your application needs to meet certain latency SLAs. So instead of serving your data from low storage, you can actually copy part of the data which is frequently used from slow storage to fast storage, basically into the cache, so that now your application can try accessing the data from fast storage. If it finds, then well and good. If it doesn't find, then it will fall back to the slow storage and fetch the data from the slow storage. So now that most of the data is in fast storage, your application can notice significant improvement in the performance. Third scenario is when your application needs to access data which is residing at the remote location. Because it is at remote location, the time it takes to fetch the data from remote location will be significant. So what you can do is put part of your data which is at remote location to the cache which is closer to your application. That way your application can access data with low latency if the data is available in the cache, and avoid hitting remote location every time. So these are three scenarios in which you can use caching. There is one more scenario in which you can use caching. That is the fourth scenario, which is to improve the scalability of an application. Let's say you have data residing in a database which can serve only 1000 requests per second, and your application needs to serve, let's say, 5000 requests per second. So even if you introduce a cache, let's say the cache has an ability to serve 5000 requests per second, still you won't be able to meet your application needs. So in order to solve this problem, what you can do is, instead of introducing one cache, you can introduce multiple caches which is fetching data one time from the database. That way your application can round robin across all these caches and serve the application needs. And this way you can technically serve any number of requests per second. So here, because you have introduced three cache, you can serve 15,000 requests per second, but you can introduce more cache and increase the volume needs of the application. So these are the four main scenarios in which you can use caching. Now, so there are mainly four types of caches that a user can use to improve the performance of an application. Let's go one by one. So the first type of cache is called isolated cache. It is called isolated cache because the process has isolated that cache within itself. So let's say you have an application which is written in Java. So what you can do is, as a part of JVM itself, you can maintain a cache as a data structure. That could be a simple hash map you're maintaining in as a part of your JVM, and this hash map can hold key and values. Key is the cache key and value is the data which you want to store as part of that key for that cache. This way, your overall complexity of maintaining the cache is reduced significantly, and you don't have to maintain a separate process. So your maintenance efforts are also very low. The advantage is that the cache is very simple. The cache is protected within the JVM, so no one else can access the cache. So you don't have to worry about the security. You don't have to maintain separate process and manage the caches. And because it's part of your process, so you don't have to maintain an additional dependency as well. So these are few of the advantages of isolated cache. The disadvantage is that because it is part of your JVM, so it is occupying extra memory. So when your cache size is much bigger, then it makes sense to actually host it as a separate process instead of hosting it as part of the same application process. So the disadvantage is that you can have only certain size of the cache. You can't have very big cache holding the memory of your JVM. So if you have very big cache, then what we can do is we can actually use the other types of caches. So next we'll check on a cache called local cache. So in local cache, what happens is you have cache hosted as a separate dedicated process. So what happens is that because it is hosted as a separate dedicated process, so it will have its own JVM and heap space. That way it won't occupy memory from your application process or application JVM. So the advantage is that multiple processes can now utilize this cache, and disadvantage is that because it is hosted as a dedicated process, so the complexity of the cache has increased now, because now you have to worry about inter-process communication, security. You have to ensure that only certain processes can access this cache, not every process can access this cache. And even you have to maintain logging and ensure that the process caching process is always up, and it can become a single point of failure as well. For example, if the cache goes down, then multiple processes can get impacted. So these are few of the disadvantages of having a dedicated cache. And the other disadvantage is that, let's say if you have processes hosted on other servers, then they can't access this cache, because the cache only gives you inter-process ability but not ability to connect it over the internet. So, and the third disadvantage is that because a server can have only limited memory, so your cache size is restricted to the memory limitation that your server possesses. And the big restriction is that your cache process should always be available on the same server where your application processes is running. So in order to avoid all these restrictions, we'll start discussing about our next cache, which is called global cache. So in global cache, instead of maintaining a dedicated server on the same dedicated process on the same server, we maintain a dedicated cache on a dedicated server to host just the cache as a separate process on the separate server itself. If we host it this way, the advantage is that now your cache size is restricted to the complete memory limitation that that server impose. But the advantage is that there are multiple processes, even if they are hosted on separate host, can now connect to this server and connect to the cache and access this cache. So the complexity of this cache increases, because now the caching technology has to handle network connectivity, network failures, low latencies, retry timeout, and lot of that factors which is related to network. It also has to ensure that some level of security is maintained, so that only the processes which are supposed to access the cache are accessing the cache, and no other processes are accessing the cache. So because now your cache is hosted on a separate server, and now you have single point of failure, as well as you have a risk of cache not being able to access if the network goes down. So from a risk point of view, you have a single point of failure, as well as it now gets impacted because of network connectivity as well. So if you want to solve this problem, we can actually invest in next type of cache, which is called distributed cache. The advantage of distributed cache is that instead of hosting your cache on one dedicated server, you're hosted on multiple servers, and they form a cluster of cache. This way, your caching technology can horizontally scale and host cache without any physical limitation restricted by one particular server. The disadvantage is that now your caching technology has become very complex, because not only it has to take care about the network connectivity, it has to manage the cluster and ensure that if a node gets added or if a node gets removed, it actually tries to elastically maintain the cluster head and slave. Apart from that, it also has to ensure that all of the nodes in the network are in sync, and also it has to always elect who should serve the request from a particular process for a particular region of cache. So it brings a lot of complexity, but the advantage is that now you don't have a single point of failure. Even if one or two nodes goes down, or even certain part of your network gets failed, your process can still be able to still be able to access the cache. The second advantage is that even the performance of the cache will improve significantly, because now process can connect to multiple servers and access your cache in parallel. So even before, there was one dedicated server, so your access to the cache was limited to certain bandwidth that got allocated to that network. But now, because of multiple servers, your bandwidth is increased, so your cache throughput is increased and your latency is decreased, because now you can get access to cache from the nearby node as well. So disadvantage is complexity, but the advantage is fault tolerance, replication, which will improve the performance as well, and your cache size is not limited to the server memory restrictions. So these were the four types of caches. Now let's talk about the different properties of the caches. In the market, we have really good caching technologies available, right from Hazelcast, Ignite, Gigaspaces, Infinispan, and Aerospike, which are very good distributed caches. You can use it as a global cache or local cache as well. There are few caches like Redis cache, Memcache, EHcache. These are also used significantly by as a local, global, or distributed cache. So I would suggest do spend some time on all of these caches, and this will really give you a really good perspective about which cache should be used in which scenario. Let's move on to our next slide. So let's talk about our first property, which is the loading strategy. So when you initialize your cache, we have two options: either initialize and load your cache as empty cache, or load it with some data. So if you load it as empty cache, it's called lazy loading. So in lazy loading, what happens is you start blank, and whenever your application access any data, you basically go and get that data from the source, but you also keep populating your cache so that most frequently used data will get filled up with your in your cache, and that's how you start. The advantage is that your start time of the application will be very fast because it doesn't have to load data into the cache. Disadvantage is that initial few fetches or initial fetches will take a lot of time because it is now grabbing the data from the source, and your users will see a very non-deterministic performance of your application. Whereas if you load the cache at the time of startup with the most frequently used data, then the advantage is that your data is already loaded into the cache, so your cache miss rate will be significantly low, and users will see a very deterministic behavior in terms of the performance of an application. The disadvantage of proactively loading the cache at the time of initialization is that when your application starts, it sees a significant slowness because you are loading the cache with the data at that time. So your application start time decrease because your application start time increases because you're loading the data into the cache. So decide whether you want lazy loading or you need proactive loading. So irrespective of whether it's isolated cache, local cache, distributed cache, or global cache, this technology, this property will significantly help you in improving the performance of an application, especially during the initial accesses by the user. Now let's move on to our next property, that is, once your cache is loaded and user is accessing data from the cache, now we have to decide what happens when the data gets updated into the source. So let's say if you have one single process writing the data to the cache or writing the data to the source or database, then you can always decide that, okay, when I actually write data to the database, first I write the data to the cache and then I write it to the database, which is called write through strategy. Or you might decide that I will only write it to the database and I will not update the cache. In that case, the data which is residing in the cache is outdated, and you then need a strategy to basically refresh the data in the cache frequently, which is called write around cache. Then the third cache strategy, to update the cache strategy, is write back cache, where you are actually writing the data only to the cache and which will get asynchronously write to the database maybe after some milliseconds. That way, your writes become much more faster because you're just writing it to the cache, not to the database. So these are three main strategy which will significantly decide whether your caching technology will give you a very good performance or not. And because they all behave significantly different and all of them has different consequences, so it is very important to critically choose this property. So for example, if you choose write back cache, then you will risk the loss of data because after you write it to the cache, and while the data was about to get asynchronously returned to the database, if your cache gets crashed, then you might lose the data or that write. So it is important that if you have a very critical application customer facing, then use something which is like write through cache or write around cache. And if you have an application writes which are like um, user behavior click through stream where you have appetite to lose certain data, then better you use write back cache. So it's completely up to the nature of an application which decides which one of this property you will select. Let's move on to our next strategy, which is the cache replacement strategy. So in cache replacement strategy, what happens is once your cache gets full and you got a cache miss, then basically you are going to grab the data from the database and then update the cache. So when you update the cache, you have to basically remove the existing data and update that slot with the new data. So how do you choose which particular data to remove from the cache? It gets dictated by one of this cache replacement strategy. So in least recently used, what you do is the data which was least recently used, you use that data to get replaced with the new data. Similarly, least recently used is basically time dependent. Most recently used is again the one which was almost used before. You'll use that first in first out, or last in first out, or randomly evicted. These are mainly 6 strategies that you can pick it from to decide which slot should get replaced when you got a cache miss. Let's move on to next property, which is, so these properties are very much dependent upon what type of cache you've been using. So let's say if you have used distributed cache, then things like partitioning, replications, serializability, retries, timeout becomes much more important. Whereas if you are using isolated cache, then serializability becomes little bit less important because your cache is part of your application. So you will have access to your data structure and your domain objects within your state of the application itself. But there are few properties like time to live, lazy evictions, refresh rate, which is very, very important because the cache has data which gets stale time to time, and the stale rate decides that when that data gets stale and when do you need to prefetch the data and put it again back to the caching. So refresh rate decides that how frequently you should refresh your cache. But this properties does not get applied if you are using properties like write through cache. But if you're using properties like write around cache, then it does make sense to ensure that you have a write refresh rate and stale rate. Lazy eviction says that whenever you bring in anything, then instead of deleting it right at that moment itself, you can actually delete it only when it actually makes sense. For example, if a certain part of your data got stale, then just don't delete it, keep it anyways. But when you get new data, just overwrite it with the stale data. That way you don't have to do an extra computation to actually delete the data. Time to live says that you can set certain amount of time. So after that time elapses, your data gets automatically removed from the cache, which is slightly different from stale rate because stale rate decides when when the data gets stale, whereas time to live decide that when I should remove the data from the cache. Active eviction is like instead of lazy eviction, you actually go and ensure that the data gets removed from the cache so that you know how much data is available now in your cache. And there are actually advantages of lazy eviction versus active eviction that we'll talk about maybe in our next video, just to reduce the information overload. Now, timeout and number of threads decide the throughput. So, for example, if only certain number of threads can handle the input connections to access the cache, so that how many connections you can form parallelly decides the number of threads property. And suppose if a certain thread is taking too much time to serve the request, maybe because your database is slow, or the query which takes to grab the data is very, very slow, then the property like timeout will decide whether I should wait or you should basically timeout and release that thread. That way you will actually give chance to other connections to serve the request instead of your complete connections are blocking for few simple requests. In distributed cache, you get much more flexibility because then you can choose regions, you can choose different queues and manage these threads differently. So that is again something which we'll talk about in our next video. So concurrency and scale. Now that your cache is holding the data which is getting frequently updated by multiple processes, it is important that your caching technology should have good concurrency and scale as well, because if you are not able to scale access to your cache, then the scalability of your application gets restricted to the scalability of your cache. So if your application needs to scale, it is very important that you invest in a caching technology which has good scaling ability. And concurrency is very, very important. Ensure that the caching technology that you choose gives you very good concurrency control. That way you will actually see a significant improve in the performance of your application. So if your caching technology is not giving you good concurrency and scale, then it is like riding a bicycle, because you can't scale, you can't introduce too many processes to use the same cache. So you will actually replicate your caches and let each process use their own cache. That way you will actually see lot of maintenance overhead, and that becomes very traditional and age old. Whereas if you're using a good caching technology that gives you fantastic concurrency controls and scalability, that is like riding in flight, because it gives you significant boost in your overall performance of your application. But the disadvantage is that because riding a flight will definitely cost you a lot of maintenance costs. So that is how you have to choose between the caching technology, not only based on all these different kind of parameters and their abilities, but also about how much maintenance cost that you are ready to spend on. So thank you guys for watching this video. If you like this video, then feel free to leave comments and suggestions in the link below. Thank you.